All right, we're going to get started here. First of all, hello everyone. Thank you for joining us. Welcome to today's webinar. I'm Tim Hansen, our marketing coordinator at MIRATECH, and I'm joined by our panelists, Scott McBryde, who's MIRATECH's regional sales manager for the Western U.S., and also MIRATECH's director of environmental impact, Jim McDonald. If you have any questions during the presentation, please submit them at any time and we'll answer those at the end of the webinar. Also, a recorded version of this webinar will be made available and I'll email it out to everyone who's registered that's either made it or couldn't make it. If you're registered, I'll make sure to send it out to everyone. So let's get started. Scott and Jim, take it away.
Great, I'll get started. Thank you everyone for joining us today. What we were going to do is start with an overview of the rules, who, what, where, when, and why. That will probably be about 25 minutes. Then I'm going to hand it over to Scott to talk about the products. And we certainly want to leave enough time at the end for questions and answers. So I guess hold them till the very end. You could probably send them to Tim and we'll make sure we'll get them, but we'll spend enough time, I can assure you, even if we go over the hour, for if you want to hang in there and ask any questions. So let's just kind of start from the beginning. Let's see. If you're not familiar with California, if the California regulatory landscape is new to you, there's 35 air districts in California. So each one has their own nuances. Tracking the regulations is my full-time job. So it's something that I'm digging into every day. CARB has oversight. So that's the statewide entity that governs mobile equipment, but also kind of, they're the ones that file the SIP, or the state implementation plan, that goes to the EPA. CEC is the California Energy Commission. They get involved in power plants, certainly, but where they play in this space is usually above anything that has a potential build out of 50 megawatts. So if you're going to be putting in, 25 2 meg generators, you're going to end up with paperwork in front of the CEC to some extent. California has its own Clean Air Act, and that's the California Environmental Quality Act. In CEQA, it establishes who's the lead agency, who's going to be making most of the decisions with regards to your permit. Also has your environmental impact report and your mitigated negative declaration. We could spend an hour on just the acronyms, so we're going to just kind of whip through them. Anybody can certainly send me a note after this or ask a question later about, we can dig deeper into what each acronym means. But for the sake of discussions, I'm just going to throw them out there and then we can get back to them. So the first time any of this got on our radar was about a year ago. There was a lot of publicity about a number of data centers who were building in the Silicon Valley that were in this 50 to 100 megawatt range, which is fairly large. They had all filed MNDs to basically not be considered a power plant and to just be dealing with the Bay Area. But why this was important was there was a lot of publicity around it. There was 3 of 8 data centers actually mentioned in this article I'm showing here, Sequoia, Walsh, and Laurelwood. Every data center usually has a code name. I'm going to be using some of the code names here, but I can assure you that these are all public record. I certainly would never be talking about a customer or a specific project where it wasn't out in the public domain. Usually the nickname of the project has to do with some sort of aspect of it, usually the physical address or the road that it's on. So again, the CEC gets involved in projects that are in this 50 to 100 megawatt range. These were the ones that were making a lot of PR. Then in January of last year, so just about a year ago, the CPUC, which is the Utility Commission, started to take a look at the environmental effects of these proactive grid shutdowns. So the grid in California is holding on for dear life. It's pretty shaky right now. You've got a lot of factors. You got a fair amount of renewables on the grid. You've got PG&E, which is filed for Chapter 11, and most dominating factor is the wildfires that are out there. So because PG&E couldn't handle any more lawsuits, they impose these PSPS, or public safety power shutoffs. So they'll do rolling blackouts, if you will, if they see an area that is susceptible to wildfires. Well, the Utility Commission wanted to take a look at how many backup generators were in these areas where they were shutting the power off. Those generators would obviously then come on and create a fair amount of pollution. So they did this study. It came out in January. It was up to October of 2019. And they found that the average duration of one of these PSPS events was 43 hours. In those 43 hours, 1,800 backup diesel generators were turned on. Obviously, that's an awful lot of them. And that created 126 tons of NOx and 8.5 tons of PM. So there's an awful lot of pollution associated with this phenomenon of having to turn the grid down. The CARB and Bay Area decided that they were going to try to motivate folks to move away from diesel engines and promote other technologies, greener technologies. So they created this website in March where they talked about if you were going to put in diesel engines, how about considering these alternative sources of power? One of them was tier 4 generators rather than tier 2. Tier 2 was the standard up to that point. They called that grouping advanced conventional. They also included natural gas generators in there. They suggested, why don't you look into fuel cells, both natural gas and hydrogen. Microturbines was something that they considered ultra low emitting, and then zero emitting would be battery storage. So throughout this process and how we were kind of involved was that we were watching a couple of permits in particular. One of the Sequoia permit that I mentioned earlier was a very large data center just west of the airport in San Jose. They had been waiting to put a shovel in the ground for almost a year, and there was a lot of back and forth. You basically every month have to file a status report, and it kind of came to a head in the end of November and the beginning of December, a couple months back, where they said, all right, what do we need to do? We're at the point now where we've done so much modeling and we've done so much analysis. What would you like us to do? And the response from the Bay Area was, okay, we've done some homework and we believe now we can change our BACT levels. And on December 22nd, so the week of Christmas, they issued this letter. And this is in a packet of stuff. If anybody wants the packet of all these public documents, we can send it to you. It basically says that BACT, instead of what it used to be, and that's a long story, but it's now going to be tier 4 compliant emissions levels. So the wording is important. Certified is what comes from the factory, and that would be in full compliance for a non-emergency gen with Quad I. This is the same emissions levels, but you can achieve it through a compliant method, and that means a tier 2 engine plus after treatment. BACT is part of something called new source review. New source review is triggered when you go above 10 pounds per day. So this is very easily triggered. Just about every decent sized generator is going to trigger new source review and therefore BACT. You also are going to likely have to still do your health risk assessment. I can't think of a reason why you wouldn't. This is tricky because you can technically meet the PM levels associated with BACT, but still need further control. So we'll get into that a little bit further. But what is it big picture? What does this mean? It means every engine over 1,000 horsepower, even a single engine over 1,000 horsepower, who had paperwork on the desk of the Bay Area throughout last year. So basically anything after the first of the year. And the permit was not deemed complete. And your permit's complete when you get an authority to construct. That's the final end of the whole process. You get an authority to construct, then you're good. So if you hadn't gotten your authority to construct and you had an engine over 1,000 horsepower, this new BACT ruling was going to affect you. You were now going to have to consider emissions controls if you were still wanted to put in a diesel engine. Quite often in the Bay Area, people have been putting in, because of the health risk assessment piece, have been putting in diesel particulate filters. What makes this different is you're also going to have to put in NOx, some level of NOx controls, and we'll go into that in great depth. On the same day, they issued a frequently asked questions document. We've been in touch with them almost weekly, the Bay Area. They're going to come out with a second version of this with greater detail. They haven't yet. In it, they just basically address these 5 questions. What is the BACT guideline? That's what we've been covering. What permit applications are affected? Anything that was, your permit paperwork was still open anytime last year. What if the engines are proposed do not meet the BACT 2 standard? They're saying you can put on after treatment devices. what happens if your application fee, let's say you decided because of this ruling that you didn't want to put in diesels anymore, they're not going to refund your application fee. And what if an authority to construct is already issued? If your authority to construct, again, is already issued, then you're fine. This should not affect you. So the Bay Area, so again, there's 35 districts. This is what the Bay Area covers. So, you know, up to Santa Rosa. And why it's important is because it goes south and includes Silicon Valley. You see on the south side there where San Jose. So this is a snapshot of just some data centers in the Silicon Valley. It's aptly named. These data centers are everywhere. There's a really large population of them, and just about all of them have diesel engines. So this is just to give you just an idea visually of how many people are affected by this rule. But even if you zoom in a little closer, you can see just west of the airport is a really large concentration of these data centers. And of the 3 of the 8 that were called out in all these public documents are located here. This one has 56 3-megawatt units. Then you've got your Sequoia, and then another data center. There's no reason to put the names in there. But you can see there's these are all applications that were currently in there. As of yesterday, so again, the rule comes out the week of Christmas, and then these data centers or anybody with an application has to give status reports, have to file monthly what their intentions are or what progress they have made. So the status reports as of yesterday, the Sequoia letter came in on the 20th saying that they are going to put in Tier 4 compliant diesel engines. They're still going with diesels and they're going to put on the after treatment. The Great Oaks letter came in about the same time, the same week, saying the same thing. So that it was just the Great Oaks site. And then there's another data center called the Fortune Data Center, and they also chose to go with after treatment on their diesel engines. We have been talking to a lot of end users, working some long hours, and some other folks are looking at other ways for compliance, size switching. What do I mean by that? So again, this rule affects engines over 1,000 horsepower. If you were going to put in a 1,200 kW unit, you can split that into 2 smaller engines. If you wanted to do 2 600 kW units, you could then kind of net out of this rule. And then some folks are considering switching to natural gas. Now here's the crystal ball part of the presentation. Again, these are, when I say anticipated, I put in big red letters at the bottom, anticipated equals best guess. We talk to the Bay Area all the time, so it's an educated guess. But the way this is going to play out is when the first permits for people who put in the controls get negotiated, it's going to set the precedent. So here's what we think is going to be that the additional requirements associated. Again, you put in your diesels, you're putting in after treatment. What are the testing requirements going to be if you're going to do this compliant path? We know they're going to ask for a NOx test. There's no way they're not going to ask for some sort of NOx test. What we believe it's going to be is EPA Method 7E. What is Method 7E? It is 3 full load, 1 hour tests that are averaged. So if you're familiar with the certified product, it's a 5-mode weighted average. This is testing at full load for 3 individual hours, and then it's averaged during that time. This is an excellent, it's probably the best case scenario because an after treatment device works very, very well at full load from an exhaust temperature standpoint, and load fluctuations sometimes can make things a little hairy. So it's actually a positive result. We asked them about, all right, let's say you're putting in 54 engines, how many engines are we going to have to test? They did concede that it will likely just be a sampling of engines. And what I mean by that is, let's say the first phase of the project is 10 engines. They might ask you to test half of those. But we believe that as you build out in phases, if you don't change engines and you don't change control devices, you'll likely be able to rest on the performance of that original set as much as you can. So we can't promise you anything, but that's the kind of the way we think they're headed. I don't think there's going to be any CO analysis that needs to be done. If they do require, if they ask for something like Method 10, we're going to counter with a proposal to do a portable analyzer. I don't believe there's going to be any POC testing. This is a very, very expensive test. It's typically FTIR or method 23. We're going to try to avoid that. And because the oxidation catalyst that's part of our system works so incredibly well, that the HAP should be down in non-detectable levels. So I don't believe the testing is going to be required there. The trickiest part of all of this is the PM testing. So if you're familiar with what's happened up to this point, a lot of these data centers were putting in particulate traps or soot filters, DPFs. And CARB had a verification program where if you put that DPF through the testing as part of their verification process, the end user didn't have to do an emissions test, because if they bought a CARB verified filter, we have two different types, but I'm just basically saying it really took the burden of the testing off of the end user, because if they bought a verified filter, they were fine. The thing that's tricky about the wording of the verification process is if you put it currently in a box with SCR, which is the way we're going to package these things, the verification is no longer valid according to CARB. The good news is that the Bay Area is the ones that are going to dictate what the testing requirements are. And if we can tell them in writing, look, it's the same device that's currently CARB verified, it's the same sizing that's currently CARB verified, we should be able to convince them that the performance will be exactly the same and we shouldn't have to test PM. That's what we're hoping for. So what are the operational modifications if you put in these controls on your engine? How are you going to have to operate your data center differently or your engine? The SCR system, you're going to have to do a full load test. So how you do that initial compliance test after commissioning is up to you. You rent a load bank, you put in a permanent load bank. Most folks, I believe, will rent a load bank for this test and then hope that maybe the testing interval will be such that you won't have to rent one again for a couple of years. What we think is going to happen is, if, let's say, your data center operator likes to exercise their engines at no load for half hour every 2 weeks, we don't believe that this rule is going to make you change that necessarily. And why that's important is any SCR system needs about 570 degrees F. It's a catalytic converter. The chemistry only works with heat. It's going to need about 570 F for it to come on and do what it's supposed to be doing for NOx reduction. You're probably not going to hit that in your half hour at no load. So when you're exercising your engine, you likely won't get any NOx reduction. The Bay Area knows this. We've been through this a number of times with them, and I think we've educated them. If we need to educate them or tell them more about it, if you write into the permit you have to load your engine to get the SCR to come on, it's counterintuitive. We call it pollute to control. You're actually burning all this extra fuel. You're creating all this extra pollution just to get your pollution control to come on. It's nonsensical. So we hope that they will let you still exercise the way you want to exercise. And then the only expectation would be if the lights go out or a PSPS event happens, your device will work very well. Your DPF, and the SCR is not going to be damaged at all if you operate it the way a data center normally is. Your DPF, this rule is not going to make you operate any differently than you would have normally operated a DPF. So if you already were operating DPFs, then you're used to the whole ramifications of having that control device. If you have an active DPF, it's self-regenerating. You don't have to really do anything as far as changing of your operations. If you have a passive DPF, there's a monitor on there that tracks back pressure. You should monitor your number of cold starts a minute at idle, and then you're going to load that generator as needed to regenerate the filter. Probably the scariest part, if you haven't done these before, of the whole thing is the idea that, and Scott will go into details about how an SCR works, but the SCR, it's very similar to the chemistry is exactly the same as what's on highway right now. You're injecting a chemical into the exhaust in a very fine mist, and it's going across the catalyst and reducing your NOx. So that chemical needs to be stored on site. DEF, diesel exhaust fluid, 32.5% urea, it's all the same thing. AdBlue, it's all the same. It's this chemical that you need to reduce your NOx. It's widely available in the Bay Area. We can assist with the supply agreements. If you haven't bought it before, we could set you up with a number of different manufacturers. We can actually help you do the supply agreement where if you saw the concentration of data centers, if you and 4 of your neighbors are all buying small quantities, perhaps you can tie together your delivery schedule and get a much greater discount. Not that you're using a lot of this, because on a 2.5 megawatt engine, for example, you're only using about 12 gallons an hour. So if you wanted a 24-hour supply of DEF, it's less than 300 gallons, that's per engine. And we have all kinds of different tank configurations. It's non-hazardous, so urea is a fertilizer, 32.5% urea in water. If you spill it, you can wash it down with hot water. It does need a hazardous material business plan. That's a local filing with your county or your city or your fire department. It's really just paperwork. It's not covered under the federal or state risk management plan, which saves you a lot of headaches. There's a picture there of a DEF tank. It's not too complicated. It's cross-linked polyethylene, glorified plastic tank. Product availability in the market. So if all of these data centers are going to be looking at controls, is there going to be product available? We're good. We have manufacturing. We have 4 different manufacturing plants. Yes, we're busy, but we're geared up for growth. Right now, we fully expect the delivery to remain pretty much where it is today, about 14 to 20 weeks, which is not too different than your diesel generator. My job is also including permitting assistance. So just about all of the people, all the data centers are going to have professionals. Now, I'm kind of an amateur in this whole thing, but I will work alongside your Rambo, Trinity, all 4. There's a lot of really great professional environmental consultants out there, and what my role would be to take a look at the permit and make sure it matches the equipment that you're purchasing. You want to make sure the emissions guarantees lie up. You want to make sure the operational parameters line up. You don't want to be buying a passive DPF where you need to periodically load the engine over 30% to get it to regenerate, and you're not allowed that by the way your permit is constructed. So we're going to work with your environmental consultant to make sure that all matches. And then engineering assistance, we provide, even well before the order, we provide what we call a pre-submittal package, drawings, electrical diagrams, just about everything, so that either if it's an indoor or an enclosure, you're going to be able to have everything you need to price up the installation of the system. One thing that was a little unique to the Silicon Valley is people love to stack enclosures in the Silicon Valley, and it's a real estate phenomenon. Obviously, land is not cheap, so we have a number of different designs where if you're going to stack the enclosures, we've figured out ways to either put the device in between the 2 generators if there's a gap, if you give us a gap there, or you can put 2 on top as a 3rd floor. So kind of whipped through that, but I wanted to make sure that Scott had his time. And then again, any questions there at the end? Scott, I'm going to hand it over to you.
All right, so yeah, we're going to kind of just work up a few technologies that may help in compliance with this ruling. Really, what we're looking at are going to be 4 constituents coming out of a diesel engine are kind of covered under the Tier 4 type regulations. When you think about that, there's particulate matter. That's the blacks that you would commonly see coming out of an engine. There's hydrocarbons, which are emitted. They're not seen, but may have some odor. You may smell that. There's CO, which is emitted. There's no sight or smell on that. And then the 4th item I show on the right here is NOx, and this is commonly referred to maybe the yellow haze you may see in a power plant running. At the bottom of this page, you'll notice that we do list the rules as defined under the Bay Area AQMD, which are in essence the Tier 4 regulations. First thing we can talk about would be a diesel oxidation catalyst. This diesel oxidation catalyst will generally reduce the hydrocarbons, the CO, up to about 90%. This is quite common. Also can remove your particulate matter as well, about 25%, but it's not covered what's called BACT, best available technology. Therefore, that is why generally you'll have a diesel particulate filter that would be applied in that regard. The oxidation callus is something we see here as a picture of it. The metallic design. It's going to be a palladium type callus, and this into a hot of some sort. They're very durable. You normally don't need any type of chemical cleaning for thousands of hours, and therefore you're not going to need to do any real service on this item. What we find on standby and low usage hour applications is that the servicing is going to actually be minimal. We talked then about a diesel particulate filter. This is what's going to remove the black soot. What happens here, you see these are generally a block that goes into the design. This product that's going to remove and filter and trap and capture the diesel engine exhaust. And so this picture here of an exhaust flow left to right, and that captures that soot. And then over a period of time, as these filters capture that soot, they're going to need to remove that soot, a term that we call regeneration. In terms of that regeneration, how do they work? This is where you're basically going to burn off, oxidize the trapped soot that's in the filter, and they're very efficient. You'll achieve anywhere from 85 to 90% filtration efficiency. And there's generally two different boxes that are applying of the technology. One called passive regeneration, you see on the left. These are a lot of stationary applications, but it is something that really, when we say passive, it's just the filter itself, and it's going to rely mainly on the exhaust profile of the engine. And that temperature is going to vary from manufacturer to manufacturer based on the technology that they're providing. And then the other box would be called active regeneration, which is really good for unique duty cycles. It's not dependent at all on the engine operation, and the active technology will be a continuous regeneration. One is, again, when you think about filters, there is an ash cleaning component that you may hear about, much like if you burn a bunch of wood in your fireplace all winter, you have all the ash at the end of the winter, you've got to clear out. But the cleaning interval is quite long, about 2,000 hours. So we don't envision, again, that you're not going to need any service on standby engines for that component. Commonly, these filters are put into a house. There's just one row of this technology as the exhaust engine is captured, and so it's very straightforward. And here's just some examples you can see of some larger horsepower installations that have been installed to meet various rules around the country. And that's within that design. You can get you can add the oxidation portion to it. If you can up the technology ladder, then we get to the fourth part, which is the selective catalyst reduction. So unfortunately, Mother Nature is not kind, as one bullet can kill all. So we have to go into an NSCR system for the removal of the NOx. We do a real quick diagram here, just kind of shows some engine outs. You bad guys that come in, you may have an cat. You'll probably have an air and a dosing system that'll come together, and with that hot exhaust, you inject that urea that Jim mentioned earlier, and we'll do a nice decomposition into ammonia. So ultimately, a lot of this is going on so we get ammonia that's going to go into the SCR catalyst, and we end up with clean exhaust. Basically, we get nitrogen and oxygen and water and CO2 at the tailpipe. So if you take that diagram and you apply it to what we're really looking at in the real components, this is the SCR aspect of that. And you can see in the lower right-hand corner, you have a control box, kind of the brains of the operation. The red lines you see are electrical outputs, including going to be an engine run signal. And then you have some of the componentry. You will have a urea tank, the urea that Jim had mentioned. The blue here is showing a injection of that urea, and components that are part of these systems, including a small booster pump to deliver the urea, an air compressor. We like to air assist with the injection of the urea so that we can help mystify, for lack of a better term, that injection of the urea so that it will do a real good job of breaking down and coming into the SCR for a very efficient reaction. We also include some tank level indications or some differential pressure switches as well, some of the additional items that may help with making sure the system, where you see this is an oxidation catalyst. You could also put a diesel particulate filter here. So you have additional components that can be added. So if you try and take all those individual pieces we just talked about, the technologies, and then bring it together for compliance, what do we end up with? Well, you can end up with some individual parts and pieces. That's probably the basis. These are good for where you have a diesel particulate filter, your mixing section, you have an SCR. Maybe you have a situation where individual pieces are going to be the best design inside buildings, hanging above equipment. We've had really complex installations that they needed to have done that way. And in fact, we even maybe some retrofitting where you can skid it. So here's an example where all that equipment can be put on some type of skid or form that can go over a generator or over an engine is needed. If you think about how the market's trended, they say, well, we'd like to try and get all that into one box. So we've come up with a design, as others in the market, that allows for a design package that can incorporate the catalyst systems into a single box. You see here the oxidation elements, your DPF blocks, and then you have the SCR blocks. Now I do note here that this is not the all-encompassing. You still need your controller, dosing box. Those accessories we noted for the SCR portion are going to still be needed, but are not shown here. In terms of design, it's really good, and where it fits well with this regulation is it's something that's going to be targeted at the 1,000, let's say 1,000 kW, give or take or above. Really compact. If you have some space limitations, what I state here is this is going to use a passive DPF technology. So the front end of this is going to just have that passive, rely on the engine to do the work of the temperature profile. And on the right, you just see a few installation examples. So in a sense, if you have a large enclosure, you're going to put a box on a box. The second half of that is you can say, well, I like the active technology. I like the active filter technology. We can do that. You can then integrate in the front end what we call an AT4, which is then taking the same thing, an integration of an active DPF technology, as you see on the right, with your active modules and your control panels to provide that. So the SCR and the oxidation portion is the same. What we can do is interchange the DPF technology to meet the customer need. And then we'll talk about, just finishing up with some of the components. There are a couple options in terms of component packaging. So you can look at a design that can incorporate all of those components that you saw in the SCR picture into one enclosure. You can include it with a base tank, a urea base tank. There's quick connections on here, a weatherproof type enclosures. This is sometimes good for clients that want to have everything be packaged and not try and put it into the enclosure manufacturer's basket. And even on the small cost-effective side, we can take those components and simply just put them on a skidded setup up to a small urea tank from 25 to 100 gallons. Some customers have different requirements. They may only want to run 4 to 6 hours of run time, up to 8 hours. And this is when you don't have no room possibly in the enclosure for these added items. So with that, that's what I've got, just to kind of cover the parts and pieces, and thanks for your time.
just want to say thank you to everyone who's attended today. Our website you can see is listed on this last slide. And if you need anything, feel free to reach out. Thank you and have a great rest of your day.